piecewise defined functions. So first we're going to talk about how to graph piecewise defined functions. So here's the piecewise defined function. It's a graph done in pieces. There's this top piece here and this other piece here. For this top piece, that's only defined from -2 to 2. And then for the bottom one, it's only defined from 2 to 4. In between 2 and 4. So first question is, let's find f of -2. So we'll do that right here. F of -2. So the key is this part right there. This lets us know what part of the graph we're using. So f of -2, that is less than or equal to 2. It goes right here. So I'm going to use 4x, right? 4x only use if this thing holds. F of -2 will be on this side. So only thing I do is substitute this into 4x. So 4 times -2, which is -8. So that's what f of -2 is, right? It only goes into it only goes into the function it satisfies. It satisfies this top one. So then we go to B, f of 2. Now both of these mention 2, but one has an equal to sign, one doesn't have an equal to sign. So it's again going to go to 4x because that's where my inequality is true. So we're going to type it again, 4x. And we get 8. Then you go to C, f of 4. So 4 is it goes for this bottom function here, right? X is less than or equal to 4, so this is where it's true, this is where it holds. So I substitute into this function. You get -2 plus 9, which is positive 7. So that's how you evaluate on a piecewise function. You should only get one answer for each, and you just substitute into the corresponding function part. Okay, let's talk about how to graph this. So D, we're going to sketch these graphs. Just making a little XY chart here. Okay, so a couple ways to graph this. I don't like that color. There we go. Graph what I need. So 4x plus 0. And that's the trick to doing. That's a trick to that linear line right there. Make it plus 0. So I start at 0. My slope is 4 over 1. So I'm gonna go up 4 and over 1. So right here. So my graph shows something like that's not good. Not good. Just try my best. Okay, so that's 4x. Now here's the thing though, I only want between -2 and 2 on my x. So on my x, I want between -2, which is here. Right, that's where -2 is, go circle. And I want and 2. So 2 goes all the way up here. That's the only part of the graph I want. I don't want any of the rest. So I can erase. Oh, it's not going to work out well because I think it erases everything. Let's see. Let me use it erase by doing white. I don't need this part. Or this part. Right, the only part of the graph I want is of 4x is when it's between -2 and 2. So that's this graph right there. So that's one way to do it. Another way to do it is by using the points. We got the endpoints here. Right, 4x, I know it starts at -2, so it's substituting -2, which we did earlier, and we got -8. So I have the point -2, -8, all the way down here somewhere. And then the other point, f of 2, right, this corner right there, we're going to plug that in there. We got 8. So you get the point like this. Something like that. Right, so same idea. So that's this graph done. Now you got to graph this other one. So again, two ways. You graph that line and it's only keep the part you need, or you could use the endpoints to connect to make your line. So if I was doing my endpoints, I actually don't have f of 2. I only substituted in for the top one. I didn't substitute in for the bottom one. So let's do this in green. Right, I'm going to do this equation. Let's figure out what f of 2 is so I can find the left endpoint. That equals -1/2 times 2 plus 9. And I get -1 plus 9, which is 8. So at 2, I'm going to be at 8. So exact same point. And then, on my f of 4, at that one I do know, is that f of 4 we are at 7. So f of 4, we're at 7. So it only goes down a little bit. So there's my piecewise graph. something like that. 2, 4. Something like that. So again, two ways to graph. We're going to do a couple more graphing, but one way is just to graph the function like you know how to graph it, and then erase, only keep the parts you need. Other way, since you know your endpoints, you can just substitute it in and find your endpoints. Let's do another one real quick. F of -3. So again, we're going to try this. So A wants f of -3. And remember, we should only get one answer for this. Where does -3 fall? Well, -3 is less than 0, so I'm going to use this equation. -3 plus 2, which is -1. And then B, we want f of 0. So remember, f of 0 is the only plugin is the one that has the equal to sign, which is the top one again. So 0 plus 2, which is 2. And then f of 3. Right, so 3 is greater than 0, so it goes into the bottom one. 1/2 times 3 squared, which is 9/2. So that's how we evaluate it. Again, we're trying to get one answer for each. You just substitute it into the corresponding equation. Now they want me to sketch the graph. That's how I can do it. Okay, so let's graph the first one first, x plus 2. So again, a couple ways to graph this. I'm going to do I know how to graph x plus 2. So you go up 2, you have a slope of 1. So my graph would normally look like this, right? But I don't want the whole graph. I only want it when it's when x is less than or equal to 0. So where's x equal to 0 at? Right here. I only want this part and then less than. So again, less than 0, not all I want is the y value. So where's the y value less than 0? That is on the left side. So this is just saying I want the left side of the graph. So I want this part of it. And I don't need the right hand side of it. I can erase it, I could leave it dotted, either way is fine. Then let's do the bottom one. I'll do that in orange. 1/2 x squared. So how do I graph that one? Well, we start at 0, 0, because there's no vertex. My slope is like 1/2, so I'm going to go over 1 and up 1/2. And that's how the slope thing kind of works. That's how my vertical shift works. So it's going to look like that. Do the same thing on the other side. So my graph kind of looks like this. Now, what part of the graph do I want though? I only want the part that's greater than 0. So here's x, here's 0. I only want this side of it, the side greater than 0. So to the right. Now, and also this has to be open circle right here, so I can mess that up. So let's make that white real quick. Put it to the normal grooves like this. I want to be the open circle and then to the right. Right, so the only part of my graph that actually counts are the solid portions. So this one to the left side of 0, and this graph to the right side of 0. That. And we get this piecewise function, right? A graph with 2 different pieces. Is f continuous on the domain? No, it's not, right? These do not connect. The other one we did, I wish I didn't answer, I guess. It is continuous on the domain. See how it connected up there, my ugly graph? It did connect up there, though. This one, they do not connect. One point goes here, one point goes there. So it's not continuous. Problem is that x equals 0. Next one, we're going to graph one more of these. So this has 3 things. But we're going to do the exact same thing we did with the last one. Just take it one step at a time. So I'm going to graph the first one first, x plus 1. Let's do that in orange. Remember, the way you graph x plus 1, just go to positive 1 and the slope of 1/1. So something to that effect. Right, and I did it dotted because that's not my final answer. My final answer is I only want it where x is less than 2. So my x, I'm going to go to 2. If you want to know what point that should be, just substitute 2 into the equation. That should be at the point 2, 3. So 2 and up to 3. So the right point right there. It is a closed circle because that's an equal to sign. And then the only thing I want is the left of x. So here's 2. Right? This only wants stuff less than 2. So everything that's less than 2. So this portion of the graph. So everything to the left of 2. So we're going to get everything down here. That's the part of the graph I want. I can either erase this or leave it alone, leave it dotted, whatever. Next one. I want 3 between 2 and 4. Well, 3 is actually this graph there. It's the vertical line at 3. So 1, 2, 3. There's a vertical line at 3. Sorry, a horizontal line at 3. Right, so you follow the tally mark. So here's y, go to 3, horizontal line. Now I want that between 2 and 4. So here's 2. It's the exact same point. So what happens when you have an open circle and closed circle? Closed circle will win. So this is just a closed circle. And then we're going to go all the way to 4. So right here. So this would have been open circle on the left side, but I can't write it because there's really a closed circle there. Closed circle wins. So one part of the graph I want is this right there. So that's x equals 3 from 2 to 4. And look at it. It's continuous at 2, right? It connected. I don't know about 4 yet, but I know at 2 I'm continuous. And the last graph we're going to do, negative 2x plus 7. This graph, so we're going to start at plus 7. Let's see, 1, 2, 3, 4, 5, 6, 7. I don't have it on my grid, so it starts there. Then we'll go down 2 over 1. Down 2 over 1. So something like that. Now, only part I care about is when it's greater than 4. And if I really want to, I don't have to keep on going. I could just substitute 4 and see where we start. You substitute in 4 into the equation, you can see what our starting point is. Negative 8 plus 7 is negative 1. So I have the point for negative 1. That's where I should be starting. An open circle. Right, so you start there, and then my slope is negative 2. So I just go down 2 over 1. Just like that. So there's my piecewise graph. It's right here that goes all the way to there, and then this bottom portion there. Is f continuous on the whole domain? No, it's not. It's not continuous at negative 4. At 4. Right, at x equals 4, I am not continuous. I have to stop. If I'm trying to draw this all of one pen stroke, I would have to stop right there and jump and draw this one. So it's not continuous at 4. Given domain and range. I don't think has that been a question on the other ones? No, it has not. Okay. Domain, left to right, looks like it goes from negative infinity all the way to 4, but then 4 to infinity, so I can put everything. Range, my lowest is negative infinity, arrows, arrows. My highest is 3. The thing gets past 3. And there's that function. Again, a little ugly. I can make it a little prettier if I wanted to white out all the extra graphs we don't need. Right, you can see our piecewise function a little easier now. Okay, next one. How about if we go backwards? I want to write a formula for a piecewise function. Now there's a couple key things. So first, I'm going to write f of x here. And it looks like it's 2 functions we've got to draw. So do something like this. Here's where our equation goes. So once we find our equation, put it right there. And then here's the partition. Where does this graph break up? If you look at it here, it breaks up right there. Right at 1. So one of these is going to be when x is less than or equal to 1, and one is when x is greater than 1. Why I put less than or equal to? The closed circle. Closed circle is less than or equal to. So if I say closed circle, I'm going to put the equal to sign, and the less than, the left side, numbers less than 1 is equal to, numbers greater than 1 is greater than 1. So all we're going to do is come up with the equations for these lines. We should know how to do that. A couple ways of doing it. You do y minus y1 equals m x minus x1. Or if you have a graph, you have y equals mx plus b. I'm going to do that first with this one, the left one. I know my y-intercept is. It's 0. So all I got to do is find my slope. Well, start there, go there, over 1 up 1. So m is 1. So my equation for this line right here is y equals mx plus b, or just y equals x. How about my equation for the other one? So if you want, you can extend it and then try to find the y-intercept, or just find 2 points and do this equation. So there are my 2 points, right? I can find a slope with lots of different ways. I could do the slope equation, m equals y2 minus y1, blah blah blah. Or you can just do rise or run. Looks like you go down 2 and over 2. So my slope is -2/2, which is 1. I need to plug a point in there to get the equation. I'm going to use the easiest one, 3, 0. And my equation is y minus 0 equals 1, x minus 3. Now when you put it into the equation, it has to be y by itself. So well, 0 is nothing, but if it was like, if I tried 1, 2, I'd have to move over the 2. Or the 2. You have to get y by itself. So in this case, we got lucky. I just get y equals x minus 3. And that's not right. My slope should be -1. There we go. It should be the negative. -x plus 3. Right, why was it? I was like, why did I stop and say that's not right? Because if it was x minus 3, it should be down here. But the y-intercept was at 3, and it's like, something's off. I forgot the slope was negative. So it's -x plus 3. That's my piecewise function. Let's do the same thing for this bottom one right here. We're going to do it again. So I know it's going to be a function. It looks like there's only 2 partitions. And where does this separate at? It separates again at 1. So one's going to be x less than 1 and x greater than or equal to 1. Now again, this time it's only less than 1 because it's an open circle on the left side. And then greater than or equal to on the right side. Now this graph right here, this looks like a normal cubic graph. So it's a cube root of x. There we go. That's the left side graph. Right side graph's a line. So again, if you want to do a line, you can do a couple of things. You can do y minus y1 equals m x minus x1. Or you can do y equals ms plus b. This is generally easier when you have a line, like in a y-intercept. I don't have a y-intercept. So I'm just going to do this one again. I'm finding a slope and plug in a point. So my slope looks like 1/1 again. So my slope is just 1. And again, you can plug any one you want into this equation. I'm going to use 2, 3 this time. X is 2, y is 3. So I get y minus 3 equals 1, x minus 2. Y minus 3 equals x minus 2. Now again, if you want to put it into the equation formation, it has to be y by itself. So I got to actually move over the 3 here to solve this equation. And I get y equals x minus 1. And so double check that looks like it should be plus 1. It's because I can add. -2 plus 3 is positive 1. So there we go. So that's why I checked my work, right? Like it should be a plus 1. It is a plus 1. I just couldn't add for a second. So that's how I write an equation with a piecewise function. The key is figuring out where it breaks up the 2 equations, and then find an equation for each one. Have been the whole time? I'm sorry. I didn't realize I was using only like 8% of the screen. Anyway, next one, the greatest integer function, also known as, aka, the round down function. So this is a round down function. If you see that particular insignia, that means we're rounding down. So what that is the piecewise function. It's x is an integer, and then the greatest integer less than x is that integer. So you can see this equation right here. So basically, if you get anything between these 2 whole numbers, it goes to the bottom number. So look here from 1 and 2, right? It's the line 1. So anything less than 2, you just go to 1. Anything less than 3, you go to 2. Anything less than 4, you get a 3. So it rounds down. That's what the graph looks like. If you put it into your calculator, it looks like this. What is the domain? Well, -infinity, positive infinity. What's the range? Interesting, it's only ever like nice solid number. It's only ever integers. That's the range. You never get any between stuff, just integers. So that's called a round down function. So let's practice. So we're gonna evaluate each of these for the greatest integer function. So a, right? I'm gonna figure out what this of 4 is. Now the key thing is you round down. I have 4, that just rounds down to 4. B, again, I'm gonna round that down, but that's a whole number. You just get -5. C, 2.46. Again, it's called a round down function or greatest integer function for a reason. We're gonna round this down. That goes straight to 2. D, you get pi. Now we're getting fancy. Pi is also known as 3.14. So we're just gonna round that down to 3. Right, the greatest integer function. E gets a little tricky. We're going to round down -6 1/2. So remember, it's a negative number, so when you round it down, you're actually rounding it to like the left side, which would make this -7. So this is probably the one where the graph would actually help you if you look at the graph. Right, when it's a negative number, you round, like -2.5, you round kind of to the next smaller number, which in this case would be -3. Right, negatives are smaller than bigger numbers. So that's how you use a round down function. Let's do a problem with the round down function. The graph of y equals fx gives a speed limit along a rural highway after traveling x miles. So this is the speed limit after trying x miles. So speed limit's over here, distance in miles over here. What is the speed limit at the 4 mile mark? So here's 4 miles. So we have two graphs here, right? Remember, the open circle is not a value. So you always go to, if you have a choice, you go to the closed circle. So it's 40 miles per hour. Estimate the miles of a highway with a speed limit of 30 miles per hour. So you want to estimate how many miles have 30 miles per hour. So here's 30. So we got to estimate that. Well, this starts at what? Let's say 6 to 8. So that's 2 plus, and this goes from 12 to 16. So another 4 miles. So 6 miles. Right, that's the only part of it that's 30. And then from here we have to estimate. It looks like it goes from 6 to 8. So that's 2 miles. And then we go from 12 to 16, which is another 4 miles. So there's 4 miles. There's 6 miles of highway that have 30 miles per hour. Estimate f of 5, f of 13, f of 19. So f of 5, f of 13, f of 19. So f of 5 is right here. Go up. So I'm going to say 5 is over here, not over there. So I'm going to say like 5 is... I could be wrong. Oof. So I think I said that was 6, so 5 would be over here somewhere. So I'm going to round that down to 40. Again, I could be wrong, but I'm going to say 5 is a little to the left. I said that's 6, I'm going to go a little to the left of that. Say it goes up here, which makes it a 40. F of 13, here's 12, here's 13, so it's in between these two, so that is 30. F of 19 is just before 20, so it goes all the way up here, which rounds down to, let's say, 55-ish. My approximate value for that. So that's C. D, at which x value is the graph discontinuous? Interpret each discontinuous. So where's it not connected at? Well, lots of places. Here, right, not connected. These two parts do not connect. Right here at like 6, not connected. At 8, it's not connected. At 12, and at 16, right? It seems like a lot, but it's actually connected a lot more. From all this is connected, all that's nice and continuous. So D, I'm going to say it's at x equals 4, let's estimate 6, 8, 12, and 16. So where it's not continuous. Interpret each discontinuity. That's the jump in speed limits. That's what's going on here. Anyway, that's it for that one. Last one. An express mail company charges $25 for a package weighing up to 2 pounds. For each additional pound of a fraction of a pound, there's an additional charge of $3. Let D represent the cost to send a package. Weigh graph this from 0 to 6. So he wants to graph a round down function from 0 to 6. So 0, whoops, sorry. 0 starts at the origin. 1, that's a little too close. 1, 2, 3, 4, 5, 6. And then here's my, what's that, the charge. So D is charge. So an express mail company charges $25 for a package weighing up to 2 pounds. So everything 2 pounds and below is $25. So let's say this is like $25. Will be open circle all the way to 2 pounds. So let's go like that. For each additional pound, a fraction of a pound, there's a $3 surcharge. So at 28 will be the next one. Right, the next pound, so if we go from 2 to 3, we have a $3 surcharge. Now this is going a little backwards because, right, it's 3, like 2 is the max here and 3 is the max. So it's actually like a round up function because all half pounds go up. And then we do the same thing with 4. Open circle here, all the way to 4. That'll be $31. And then from 4 to 5, it'll be $34. And then from 5 to 6, it'll be $37. And that's my function.